Hello, welcome to Maths with EJD. In this video, I'll be talking about the Barabási-Albert model, which is a very good example of scale-free networks. In previous videos, I had talked about random graphs, small world networks, and we've given specific example for random graph. For instance, we have the Erdos-Renyi model. For this small world networks, we had the what's Strogat's model, and now for scale-free networks, the focus is on the Barabási-Albert model. And like I said previously, Barabási seems to be seen as the father of network theory. I'm not very sure if that is widely accepted. Okay, so the the Barabási Albert model generates generates networks through preferential attachment. Preferential attachment. Okay, where new nodes are more likely to connect to highly connected existing nodes. To highly connected existing nodes. So this results in a power law. Power law is very popular in mathematics. This results in a power law degree. I guess I want to make that bold. This results in a power law degree. So the degree distribution will follow power law. So this results in a power law degree distribution. Degree distribution. So if you want to see the Barabási-Albert model in terms of social connections, right? It's more like people who only want to attach themselves to influencers or people who just want to be friends to celebrities because they know celebrities have very high contact. I mean, they have influence, they know people and all that, so they just want to be connected with them. So, and that's the idea of preferential attachment. Okay. So preferential attachment is key in this situation. Okay. So you see preferential attachment and of course power law degree distribution. So like the key things here. So let's talk about the key properties of the Barabási-Albert model. Key properties. So the first thing is we have the presence of hubs. The presence of hubs. So these are nodes with disproportionately high connections. Nodes with disproportionately high connections. Disproportionately high connections. On Twitter, for instance, it would be like individuals with very large following. I mean, we already know that on most of the social media networks, very few people have very large following, whereas so many people just have few followers. Okay, so you have presence of hubs, which you can call influencers in social networks. So then we talk about robustness, robustness to random failures, but vulnerability or vulnerability to targeted attacks. Okay, so imagine being an influencer, right? It comes with a whole lot of advantage. You can get all the endorsements, you can get everything. But then because you are that visible too, you can easily be trolled, you can be attacked and things like that. So I see that I can easily draw that parallel in this situation. So from the Barabási-Albert model, which represents scale-free networks. Okay, another property we have said before is about the degree distribution. And this talks about the number of edges connected to a node or the number of friends a person has, so to speak. So the degree distribution under Barabasi, we've said it already that it follows the power law, which is the power law is something like P of K, follows K raised power minus gamma, like that. So where where gamma typically ranges, typically ranges from 2 to 3. Okay. So these are the key properties of the Barabasi-Albert model. Now, let's talk about some practical examples. I've given some of my own, but let's see practical examples. So a very good example would be the World Wide Web. It's a whole revolution on its own, redefined the way people connect in modern times. So the internet is a scale-free network. It's a scale-free network with a few with a few websites like Google and Wikipedia, with Google and Wikipedia acting acting as major hubs, linking countless smaller sites. Okay. So there are many websites all over the place, right? But sites like Google and Wikipedia, things to, they are like they have disproportionate large connections. Okay. Then we can also talk about social networks. Social networks. I've been given that example a lot because I see a lot of parallel between social networks and in the Barabasi model. So platforms, platforms, uh, platforms like Facebook and Twitter are scale free with some users, like I said before, with some users, better known as celebrities, or even influencers having exponentially more connections than the average user. Okay. And we can talk about biological networks. So for biological networks, right, you have protein interaction networks in cells show scale-free properties where a few proteins interact with many others. Plain crucial roles in cellular functions. Then we also have transportation networks. Some airports are disproportionately more patronized than others because they are like serious hubs of commerce. So airline networks have major hubs. In fact, even globally, right? E.g., you have the Atlanta airport in Atlanta or Dubai airports connected, connected to numerous smaller airports, optimizing global connectivity. Okay, that is the idea of skill-free networks, exemplified by the Barabási-Albert model. So don't forget the degree distribution is exponential. Power, it follows power law, and the clustering varies. And the clustering is usually low, right? Because you have, I mean, the whole attention is on a particular, on just a few nodes. Then the average path length is short. The example application is in social media and internet hubs, right? So you discover that each model provides a length. We have seen all the three models, right? All the three models, random graphs, small world networks, and now the scale-free networks. So each of these model provides a lens through which reward networks can be understood and optimized, right? And choosing the right model depends on the system's inherent properties and purpose. So if you want to model whatever you're doing, you need to understand it, the context properly, so you can know which of these three models you can actually adapt, or maybe you want to come up with your own kind of model. Okay. So of course, though I'm still gonna show you do a comprehensive video on how the whole Python code works for this, but I'm just going to, I'll just run. I'll explain better in another video separately, but I'll just talk about this briefly here. So this is the Python code implementation for this, which I'm going to explain comprehensively later. But I'll just run it so you can just have a glimpse of what this looks like. So you see the Barabasi thing. So you have now you can see the center here. You have like one or two nodes there with all the connections, but then they're attached to smaller connections, like we have seen about airport connection, social media influencers, and even celebrities. So in the next video, I'm going to do this more comprehensively. So till then, click the subscribe button, subscribe, hit the notification bell also so you can always get alerted when a new video is released. Then comment, let me know if you want me to solve a problem or teach a topic. Then like and share so that more people can have access to all this great learning going on here. Till then, keep networking, keep connecting. Bye.